Okay, so the role of voltage, current, resistance, and power within a simple circuit. Voltage is what pushes electrons to flow through a wired circuit. It is measured in volts. Current is the flow of positive charge in a circuit. It is measured in amps. Resistance is the opposition to the current flowing in a circuit and is measured in ohms. Power is how quick or slow electrical energy is used in a closed circuit. Ohm's law is voltage equals current times resistance. So if voltage is increased, the current of a circuit will increase. If resistance is increased, the current of a circuit will decrease. If voltage is increased, then the power of the circuit will increase. So wiring in series, you want to connect all the wires in a single closed loop. You want to make sure that there is only one path that the current can travel through. The wires are directly connected to one another. Because it's a single loop, if one bulb goes out, the entire circuit will go out. And it is mainly used because the current throughout the entire circuit will be constant. So one bulb light switches use series because it only involves one bulb, so there's really no need for parallel because if the bulb goes out, there's no other bulbs that will be affected. Fridges also the temperature adjusters on fridges also use series so that the temperature of a fridge can be easily adjusted by changing the resistance in the adjuster. So wiring in parallel connect all the wires within multiple closed loops. You want to make sure that there are multiple paths for the current to travel through. To do this, have the wires go horizontally and have the bulbs go vertically. The bulbs should connect the wires to each other, and the wires should directly be connected to one another. This parallels are normally used so that if one bulb goes out in a parallel circuit, the rest won't. Some examples would be some types of Christmas lights. If one light goes out, then the rest won't. And headlights, so if one headlight goes out, the other one won't, because if it was in series, then it would be a lot more dangerous if one headlight went out, because then you would have no headlights. So in series circuits, current is constant and voltage is divided between bulbs, and resistors are added to get the total resistance. So adding bulbs increases resistance and decreases current. And the reason why resistors are added up just normally is because adding the bulbs will add more resistance. So the resistors would be additive. In parallel, current is divided between multiple paths, voltage is constant, and resistors are added up 1 over R. And they're added up this way because in parallel, adding bulbs actually decreases resistance. So more bulbs would mean less resistance. In a series circuit, if one bulb goes out, they all go out. While in parallel, if one bulb goes out, the rest will stay on. An analogy for series and parallel circuits would be like a checkout lane in the grocery store. For a parallel circuit, different checkout lanes would open to allow for people to choose between which one they wanted to use. Thus, current, in this case people, is divided. Series would be like if there's one line and there are multiple checkout lanes that everyone had to go through in order to fully check out. This would lengthen the process, which is why adding a bulb, or in this case, an extra checkout lane, would increase resistance, or in this case, time. So we're doing calculations. We're going to start with series. So some things to keep in mind with series calculations is that current is constant and voltage adds up to the total voltage, and resistors are added normally. So this example, you are given the total voltage, and you can find the total resistance by adding up the different resistors. You can find the total current by dividing the total voltage by the total resistance, basically using Ohm's law. The current is constant in this series, so you now know the current for each resistor. So now you're going to want to plug in the known information that you solve for into a table and solve for the unknowns, in this case, voltage at the different resistors. Uh, multiply resistance by current for each resistor to find the voltage at each resistor, and finally to find power, do current times voltage at each resistor and the total current. Okay. So some things to keep in mind with parallel calculations is that voltage is constant and current adds up to the total, and resistors are added 1 over R. This doesn't necessarily need to be applied to this example since you won't really need to add resistors together, but it's good to know, especially for the combination circuits. So you have the total voltage, and since voltage is constant for each, you know the voltage for each resistor. To find the total current, just add the two resistors you're given, so 1 plus 2 equals 3. Now just take the voltage divided by the current to get the total resistance, which 6 divided by 3 is 2. Plug the known information into a table and solve for the unknown. In this case, it's the resistance at the different resistors. So to find this, you're going to want to divide the voltage at each resistor by the current at each resistor. And finally, you can just find power by doing current times voltage at each resistor and the total voltage times the total current. Numbers. And finally, we are to combination circuits, which are the most complicated type of calculation. It involves both series and parallel calculations. You want to start from the furthest point of the battery. So here you want to start by adding these two parallel resistors together. So these two are in parallel, so you want to add using the 1 over R method. So 1 over 6 plus 1 over 4. To solve for 1 over R, you should get R equals 2.4 ohm. Next, you want to redraw the circuit. You should do this basically after every step because you're trying to simplify the circuit down to where you just have one resistor left. Because you just added the two parallel resistors together, the entire circuit is now in series, and you should add the top two resistors, 2.4 and 8 together, and the bottom resistors, 15 and 10 together. Because you're in series, you don't need to add using 1 over R, you can just add them normally. You should get 10.4 ohms on the top and 25 on the bottom. Next, redraw the circuit again, and this time you'll only have two resistors which are in parallel. The top being 10.4 and the bottom being 25. Just add these two together using 1 over R, and the answer in this case is 7.34 ohms. After adding the two resistors together, you wind up with one resistor left in a series circuit with a resistance of 7.34 ohms. This is the total resistance of the circuit, and we are given the total voltage, which is 12 volts, at the beginning of the problem. So we just need to solve for the total current. To do this, just take total voltage divided by total resistance to get 1.63 amps. Now you are going to basically work in reverse, basically building back the circuit to its former shape in order to find the voltage and current at the original resistors. Since we are switching to parallel, voltage remains constant and the resistance is the previous resistance we calculated. So 10.4 for the top and 25 for the bottom. Simply calculate current by dividing the voltage by resistance. The top is 1.15 and the bottom is 0.48 amps. So continue to move backwards. We are now in a series circuit, meaning that the current will be constant. So use 1.15 for the top for both the top resistors and 0.48 for both the bottom resistors. Now you can calculate for voltage at each resistor by multiplying current by resistance. The resistance we used for this was resistance we had at this point in the problem previously. So 2.4 top left, 8 for the top right, 15 for the bottom left, and 10 for the bottom right. So finally, you're going to redraw the circuit to its original shape and solve for the unknown. So the calculations of two resistors 2, 3, and 4 stay the same since they are still in series and haven't changed, but resistors 1 and 5 need to be solved for. And again, in parallel, voltage is constant, so use the voltage for resistor 1 in the last problem for both resistor 1 and resistor 5. Simply take the voltage and divide it by the original resistor to get the current at resistors 1 and 5. So 1.15 for resistor 1 and 0.69 for resistor 5. Now plug all the information you solve for into a data table, and now you can finally solve for the power. To find the power at the different resistors, just take the voltage times the current at each resistor, and for the total, just take the total voltage times the total current to find the power for the whole circuit.